In this video, we'll be going over a notebook where we tackle a problem of classifying whether a person will suffer a stroke or not. This is about a brain stroke, right? So, first of all, we look at the attributes of the problem, the data set, right? So, gender, age, hypertension, various factors are like smoking status. One thing I would like to point out here is age is like a number, right? So age goes from 0 to let's say 102, 103. These are would be mostly absolute values, right? Can be in decimals or fractions, but yeah, age is just a number which can be anywhere from 0 to any number, right? But when compared to smoking status, right? Smoking status is into four categories: whether formerly smoked, never smoked, still smokes, right? Smokes, or unknown. So while we tackle a problem, we need to handle these different types of columns separately. So these are known as categorical problems, just like our DV, dependent variable, which is the stroke, which is one if the patient had a stroke, or zero if the patient had not. So using binary classification, that is, this is a binary classification problem. Using logistic regression, we'll try to solve it. So first of all, we do a basic EDA, right? EDA means exploratory data analysis. Based on our knowledge or based on what I could understand, I plotted some graphs, which is for age, average glucose level, and BMI, to see what their distribution means. These distributions look fairly normal, right? Because age would be somewhere like 50. There are more people in the 50s, 40s, right? Similarly, average glucose level around 80s and 90s are considered to be normal. There is a peak and another rise we can see around 200. These are for maybe people with high glucose levels with diabetes, right? Similarly, BMI 20s, 25, 26 are considered healthy, normal person's BMI. So a basic distribution plot gives us how the data is spread, which is a good thing to do before we start. Now, with respect to stroke, right? With respect to stroke, how can we do this? So if we see age for people who have higher age is a prominent factor for a person to have a stroke. Similarly, people who have higher glucose level tend to have a higher chance of suffering a brain stroke. People with, let's say, a normal BMI, maybe, I don't know, we can't comment much about this, but yeah, EDL helps us basically comment on what the data is depicting. You can go into deep levels based on EDA, which will help you get the best out of a data set, what kind of salient features you can look into, right? So before going into the modeling process, this is a very important part. Again, the thing I talked about, where we treat the categorical values. We need to treat them. So smoking status, work type, I've got the dummies. What dummies does is basically get them into 0, 1, 0, 1 column, all of the categories in a column, right? This is very important. This is essential to setting up your modeling technique. So we do some basic transformations before we get started, right? So this video mainly talks about what logistic regression is. Before we start about that, let's talk about what linear regression is. Linear regression is predicting something like a price which varies from 10 to 20 in a year, right? So if there is a seasonal holidays are coming, the price might be placed around 17, 18. But if there are no holidays around, the price of an item may be placed around 11 or 12. This is a continuous value. These are continuous values, 11.7. So we can predict using a linear regression problem. If you see the equation, it is a linear equation of a line, simple, where y is the value which we are trying to predict, b0 is the intercept, and b1, beta 1, is the factor or the coefficient for the predictor x, right? And this is a constant. So there can be many predictors, as we saw above, but there is one dv or one y which we are trying to predict. Now, when we talk about logistic regression are used for classification problems. Now, as we are trying to predict whether a person will suffer a It's brain stroke or not is a classic, or basically there are two options, two categories. Will a person suffer a brain stroke or not? So this is a binary classification problem. Similarly, there are multinomial classification problems which can also be solved using logistic regression. But with respect to this problem right now, we'll be dealing with binary classification. If you look at the equation now, this this equation represents log odds of a categorical response of being true for a linear combination of features. What does each line mean? So these are the log odds, the probability of an event happening, the log of it is equal to beta naught, which is the intercept, and beta 1, which is the coefficient for one feature, and the constant. So seeing it like an equation does not make much sense, but you might understand that we are doing the transformation of log just because the result is either a 1 or a 0. So now, if I just want you to look at this graph, we fit in linear regression, we fit a line. We try to fit a line, a straight line. We fit an S-shaped curve while doing logistic regression. So when the probability is above, let's say 0.6, we say that this event is likely to happen and we assign it a value of 1. That's why this graph shows up value of 1. Similarly, if a probability is less than 0.6, this is a threshold which can be set manually, right? We say that this point will be 0, that the probability is 0. Now, based on various factors, this equation returns a value. Based on these values of beta 1, beta naught, and we can actually calculate the probability, which is depicted here, the probability of a specific class. I think it is very self-explanatory once you look into the equations. And these are for many problems, like either a person will fail or pass. Is it a yes or no? Have the people survived or either they're dead? Is the wine good or bad? Now, these are the combinations of problems we are trying to solve, right? So similarly, here we set up the pipeline for the problem. L2 is a regularization method. Basically, it tries to fine tune the bias and the variance, and C is the threshold. You can also vary it. LR is the name we have given to the pipeline. This is a very simple setup of the logistic regression model, and we just train it and try to run its report on the predict test and the test variables. We see a 92% accuracy, but AUC, area under the curve, is another feature which basically tells you how much of coverage of the true or false or yes or no is being given, right? This is very important now. Why? This is kind of basically how accurate or how well does your model perform based on these metrics. You need something to improve. When you change these parameters, these L2 penalty, you might see something different. You will see an improvement in bias rate or the results. Right now, we are more focused on what the results mean, right? These are the coefficients which we see from the results. Now let's see how do we interpret these results. As you know, the equation was log odds of a certain event, and these are the coefficients of different features. This beta naught is, let's say, this is the intercept. Age would be something 1.99 times whatever the age is. Hypertension would be, let's say, beta 2. So this is in equation. And now how do we interpret them? So we say that a 1 unit increase in age, let's say 1 unit here, will increase 1.99 times basically the log odds of the stroke. Which is simple. Once you see this and once you have visualized various things, I think it's as simple as you can certainly now comment about each coefficient and how does it affect. Now we just see what SHAP does. As you know, I've talked about theory and how the problem is set up. We basically load that model and try to figure out how does each variable contribute. Now the contributions are independent. Basically, this has taken everything into account and we can just see these the factors in color red or pink basically contribute towards a higher chance, and now the factors too in the blue are pushing the probability or the sharp values towards a lower chance. This is for a particular row, and that's where SHAP comes in and plays a very important role. It lets you understand a deeper level in the model. And this is for the logistic regression model, how each row is being affected. This is how each row is being affected for the particular row by various factors. Similarly, now we look at the SHAP values. If the person has never smoked, this contributes a lot. If it is unknown, this also contributes a lot. Age is one of the top three, as we could figure out from the basic EDA we did initially. Now we look at the SHAP value summary plot. If the person has never smoked is 1, that is a higher value on the SHAP. The person will not, the probability of suffering a stroke is low, you can see the blue color. Very interpretable. Similarly, we look at age. If the value of SHAP value, if age is high, the probability of suffering a stroke is very high, clear red. So, all in all, I just wanted to show how do we go about logistic regression and how can we interpret them. There are various other methods. I hope this video was helpful and resourceful. So, thank you.